Students, hello. Today we are going to discuss about psychrometry. Psychrometry means what is psychrometry? Psychrometry is the study of the thermodynamic properties of moist air. It is extensively used to illustrate and analyze the characteristics of various air conditioning processes and cycles. Psychrometry has great application in food processing industry where we evaluate different calculations regarding drying, refrigeration, air conditioning. Okay, so this has great application for calculation. What will be the environmental problem, environmental change during drying? What will be the air conditioning changing? Then, for this reason, we have to know the psychrometry. Okay, psychrometry. What are the important psychrometric properties? There are different psychrometric properties or name we have to know. One is dry bulb temperature, wet bulb temperature, humidity ratio, relative humidity, dew point temperature, specific volume, and enthalpy. These are the important psychrometric properties. Regulate dry bulb temperature, all of you know. Dry bulb temperature means the temperature we measure by using a instrument that is known as thermometer. When bulb of the thermometer is not wrapped, it is only ordinary thermometer, and with that thermometer, whatever the temperature of the air in environment it shows, that is known as the dry bulb temperature. Here you will get the definition is the temperature of the moist air as measured by standard thermometer or other temperature measuring instrument that is known as the dry bulb temperature. Unit is degree centigrade or degree Fahrenheit, Kelvin, all these things. But whenever the bulb of the thermometer is wrapped by wet cloth, so what happens? When air will be passing over the bulb, so air will take the moisture from the wet cloth and the temperature of the moist air will be reduced. At that condition, whatever the temperature is measured, that is known as the wet bulb temperature. If you look at this, this is the dry bulb temperature. This is the muslin sleeve. Muslin sleeve is wrapped around this bulb. But in case of dry bulb temperature, there is no wrapping. So in that wrapping condition, muslin sleeve, whatever the temperature it shows, that is known as the wet bulb temperature. And dry bulb temperature is general temperature which is measured by ordinary standard thermometer. Okay. Wet bulb temperature is the lowest temperature that can be reached by the evaporation of water only. It is the temperature one feels when one's skin is wet and is exposed to moving air. Okay. Whenever we'll feeling some due to the sweating, whatever the after sweating, if the um, skin is wet and this moisture from the skin is evaporating, then whatever the cooling we feel that is due to this wet bulb temperature. This at same condition, the dry bulb temperature is larger or greater than the wet bulb temperature. Okay, these are the two important temperature which is we have to know in psychrometry, dry bulb and wet bulb. Now another temperature is dew point. Dew point, all of you know that this is the temperature at which condensation begins. Condensation begins means generally, in every moist air in environment, air not only contains dry air, it also contains some water vapor. Now, this water vapor when becomes 100% means 1 kg water air contains 1 kg water vapor. So what will happen? The water vapor will not be sufficient to hold in this moist water. So when the temperature at constant pressure will be reduced, at that temperature some water vapor will be condensed on the leaves or grasses and it will be coming as dew. At the temperature at which this water vapor condenses, that is known as the dew point temperature. Means dew point temperature occurs when 100% relative humidity occurs. Relative humidity, I am coming, what is humidity? relative humidity, humidity ratio, all these things are coming under the psychrometry. So dew point temperature means the temperature at which the moist air means air plus water vapor. The moist air cannot hold the excess amount of moisture. Then what will happen? In that condition, the excess amount of moisture or water vapor will be condensed. And this is known as a constant pressure means at 1 atmospheric pressure it is happens. So it is known as the dew point temperature. And humidity ratio or specific humidity, this is also another important parameter inside. What is humidity? I have also told that moist air means not only the only dry air, it also contains the water vapor. So ratio of the mass of water vapor to the mass of dry air in a given volume of the mixture is denoted by the humidity ratio or specific humidity. So if it is denoted by omega, so it will be omega is equal to mv by ma. Ma is the mass of dry air and mv is the mass of vapor. So by this we can show that this is the humidity ratio. Mass of water vapor means if 1 kg of air it is, if dry air, in 1 kg dry air, how much water vapor it contains, that is known as the unit is either gram per gram or kg per kg, gram per kg. This is the unit of humidity ratio. But relative humidity is another thing. Relative humidity is the ratio of actual weight of water vapor per given volume of air relative to the weight of water vapor content in the same volume of the saturated air. You have to know the saturated air, it is expressed in percentage. Means what happens in saturated condition? Saturated condition is that condition when the water vapor will be in maximum amount. Means the dry air, how much water vapor it can hold, that is present in that air. When this condition is achieved, this is known as the saturated air. Okay. But this saturated air comes when it is comes when it will be coming saturated condition, when partial pressure. There is also another thing, partial pressure, water vapor and vapor pressure becomes saturation vapor pressure equals. In that case, this will be the air will become saturation. But the saturation condition, what is relative humidity? Relative humidity is the ratio of actual weight of water vapor per given volume of air relative to the weight of water vapor it contains and same volume of the saturated air. Means how much at that condition, what will be the water vapor present in the dry air? 2. How much water vapor present in the saturation air? At the same temperature, it is expressed. Or it can be written as Pw by Ps, that is partial pressure of water vapor in a given volume of saturated air, in a given volume of air at this temperature divided by Ms or Vs. So in this way, relative humidity is expressed. Relative humidity, suppose we can express in percentage because it is the ratio of two masses or two pressure. Okay. Generally, what happens whenever we are expressing, suppose we are telling that today the relative humidity is 60% or 90%. So what does it mean? Relative humidity 90% means if we take 100 kg of dry air, 100 kg of dry air, in that condition, whatever the amount of water vapor it contains, but in saturation vapor, in that condition, the ratio of this will be 60%, means 0.6. This is known as the relative humidity. Humidity and relative humidity is different. Humidity is the amount of water vapor present in dry air. That is known as the humidity or specific humidity or humidity ratio. But relative humidity is the ratio of water vapor present in moist air to water vapor present in saturation air at same temperature. This is known as the relative humidity. Okay. Now specific volume. For specific volume is meter cube. They all of you know. But specific volume means just reverse of the density. It is defined as the how much volume of moist air contains per kg of dry air. Means meter cube per kg air. Means 1 kg dry air, how much contains, 1 kg dry air contains how much volume of moist air. That is known as the specific volume. This is we can also calculate by either psychrometric chart or any formula. That is also different formulas are there by which we can calculate specific volume, density, relative humidity, and enthalpy. Enthalpy is the enthalpy of the moist air is the sum of the enthalpy of dry air and the enthalpy of the water vapor. Enthalpy of the dry air means sensible heat and enthalpy of the water vapor means latent heat. Now, total enthalpy is the sensible heat and latent heat. Now, I want to mention what is sensible heat. Sensible heat is generally is used or heat amount of heat required to change the temperature. To change the only the temperature from one temperature to another temperature, whatever the heat is required, that is known as the sensible heat. But latent heat is different. Latent heat is at constant temperature, how much heat is required to change the phase from solid to liquid, liquid to solid, solid to vapor, vapor to solid, or vapor to liquid. Suppose all of you know that is solid to liquid. Solid to liquid, suppose ice, ice to water. This is known as the melting, latent heat of melting. Suppose liquid to solid, liquid to latent heat of crystallization, or solid to vapor, latent heat of vaporization, vapor to solid. So this is in this way latent heat of so ice to water vapor, then it will be coming to the latent heat of sublimation, vapor to solid deposition. So these things are whenever at constant temperature, whatever the heat is required to change the phase, that is known as the enthalpy due to change in temperature, enthalpy due to change in humidity. Humidity changes for this risk, it is known as the latent heat and sensible heat. If you look at this is the psychrometric chart in which x-axis if we plot dry bulb temperature and y-axis we plot humidity ratio. From that psychrometric chart we can determine all the psychrometric properties, that is dry bulb temperature, wet bulb temperature, humidity ratio, specific volume, enthalpy, all these things. Now how I am coming to the next slide, that is the dry bulb temperature line. This is the dry bulb temperature x-axis and y-axis. If you look at this is the humidity ratio. So what will be the dry bulb temperature lines? All these vertical lines are known as the dry bulb. In the previous slide, if you look at this it will be very easy. You can not understand. So I am showing you different things, different graphs by which you can easily visualize what will be the lines. That is the dry bulb lines. This is dry bulb lines, vertical lines, and wet bulb lines is just inclined lines, which are known as these wet bulb lines. Another things, relative humidity lines. This is known as the 100% relative humidity. As we decrease from this relative humidity from this point to this, then relative humidity is decreasing 80%, 70%, 45%, 20%. In this way, relative humidity lines will be decreasing. Okay. Next is dew point lines. This will be the horizontal lines. All these things are horizontal lines. Dew point lines. All the dew point lines will touch the 100% RH lines. This is the 100% RH lines. The 100% array lines will be touched at that point. Whatever the vertical lines if we draw, then whatever the dry bulb temperature it will be showing, that is known as the dew point temperature. Okay. In this way we can determine the dew points. Next is humidity ratio. This is also horizontal lines, but here horizontal lines you have to go for the y-axis. In this axis, whatever the value we will get at this y-axis, that is we will get the humidity ratio. But dew point temperature lines are also horizontal lines, but we have to see in case of dew point temperature, the lines which will intersect the 100% RH lines. At that point, we have to go to the dye bulb lines. We have to draw the vertical line, and the vertical line which will touch the dye bulb temperature line. That temperature will show the dew point temperature. And in this case, humidity ratio, the horizontal line which will touch the y-axis at that temperature, at that point, whatever the value it will give, that will give you the humidity ratio value or specific humidity. Okay. This is known as the specific enthalpy lines. Enthalpy lines and specific enthalpy lines and wet bulb lines are also same, almost same. That is also inclined lines, which will go for, and here all these values are given by which we can determine the enthalpy value at that condition. What will be the enthalpy value at that condition? Okay. This way, and this is the specific volume. Specific volume lines are also, these are the different volume lines which by which we can calculate 15, 12. This way it will be meter cube per kg of dry air. Now some psychrometric processes are there by which and what are important in case of industry, any food processing industry, chemical industry: sensibility, sensible cooling, humidification, dehumidification, heating and humidification, cooling and dehumidification, cooling and humidification, and heating and dehumidification. Both are important processes which occur in industry, especially food processing industry during different unit operations: drying, evaporation, refrigeration, air conditioning, during storage of the food materials. These are the different for calculation of the capacity of the cold storage. Psychrometric, these processes you have to know, and you can calculate the mm, how much capacity of the cold storage you require for the storing of the food materials. Okay. Sensible cooling means amount of heat addition to moisture without addition of the moisture. Only we have to, I have also that heating, sensible heat. Heating means we have to add heat and we have to change the temperature, moisture, but we do not add any moisture. So it follows a constant humidity ratio line on the psychrometric chart. During this process, what will happen? Moisture content of air remains constant, but its temperature increases as it flows over the heating coil. So what will happen during this? The dry bulb temperature increases and humidity remains constant. Humidity, I have told, amount of moisture per unit of dry air. As here, in case of this, amount of water vapor is not adding, so humidity remains constant, but dry bulb temperature is increasing because we are adding heat. Okay. Next is sensible cooling. Cooling, all of you know, cooling means removal of heat. Means this during this process, moisture of content of air remains constant, but its temperature is decreasing because it is flowing over the heating coil or cooling coil. Previously, it was flowing, air is flowing over the heating coil, but here air is flowing over the cooling coil. So in this case, what will happen? dBT, that is dry bulb temperature, is decreasing. O is the initial point and A is the final point, and O to A is the flow of the air over the cooling coil. So what will happen? Humidity ratio, this is the humidity ratio line. In this case, what will happen? Humidity ratio or specific humidity remains constant. But here, if you go for the enthalpy, enthalpy in this line and in this line, enthalpy is also decreasing. Enthalpy is also decreasing. Next is the humidification. Humidification is the addition of the moisture. Humidification is the process of adding moisture at constant temperature. Now, whenever we are adding the moisture at constant, then what will happen? Humidity ratio will change. This happens when water at the dry bulb temperature of the entering air is spread in the chamber whose temperature is maintained at their dry bulb temperature. If you look at the Dehumidification just at the opposite of the humidification. Humidification, I have told that addition of the moisture in the air, but dehumidification is the just removal of moisture, process in which moisture or whatever humidity is removed from the air, keeping its drive-up temperature constant, is called as the dehumidification process. And this process is represented by straight vertical line on the psychrometric chart, starting from the initial value of the relative humidity, extending downwards and ending at final value of the relative humidity. Vertical lines. Okay. Because in this case, what will happen? Drive up temperature is constant, but what will happen? Humidity is reducing. In other case, the humidity is increasing. Okay. If you look at this is the 1 to 2. 1 to 2, 1 is the initial point, 2 is the final point. Now, from 1 to 2, what will happen if we increase the or if we add the moisture or humid, then what will happen? The humidification. So, at point 1, humidity ratio W1, at point 2, it is W2. So, this is the 1 to 2 is the humidification. Wait, 1 to 2 ratio. 1 to 2 process. But here you can just opposite 1 to 2. 1 is the initial and 2 is the final point, dehumidification. Here is also at point 1 W1, at point 2 W2. So this is the humid is removed or moisture is removed. So it is known as the dehumidification. So this is the vertical line. This is also vertical line. All of you have understood. This is known as the humidification process and dehumidification process. Okay, if you look at the psychrometric chart, here you can also very much, it is understood that this is the humidifying. I have told that amount of moisture is adding. So what will happen? dBT remains constant along this line, whatever the dBT remains constant, but humidity remains increasing because it is, suppose humidity ratio is 125 here in this position and here it is. So humidity in this ratio, in this direction humidifying, in this direction dehumidifying, in this direction sensible heating. Sensible heating I have told dBT will increase but humidity ratio will constant. Similarly, in case of sensible cooling, what will happen? dBT, driver temperature will decrease but humidity ratio will remain constant. So all of you have understood, and here you also get these lines. If you look at these lines are relative humidity lines. These curved lines are the relative humidity lines, and all these lines are these inclined lines. All these things you are getting. These lines are specific enthalpy lines, or we have also shown that these are the wet bulb lines. These lines are the wet bulb lines. All these lines are wet bulb lines. Okay. And this is the basic process in air conditioning. In air conditioning, it is very much applicable refrigeration air conditioning, which is important for calculation of the capacity of the cold storage in food processing industry. Sensible heating, sensible cooling, humidifying, dehumidifying, heating and humidifying. Heating and humidifying means amount of moisture is also added and heat is also added. So the curve will be following, process will be following in this direction. Cooling and humidifying, if it is process occurs, so it will follow this path. Cooling and dehumidifying, this path, and heating and dehumidifying, this path. Okay, in this direction, if you know these processes, in which direction it is occurring, so you can calculate at, suppose heating and humidification process is occur. So by this, what is the temperature? This is the initial, this center point is initial, and this is the suppose final. So at final point, what will be the relative humidity? What will be the dBT? What will be W, the wet bulb temperature? What will be enthalpy? You can calculate by psychrometric chart. Okay. If you know the process will be following this direction. In this way, all these parameters you can calculate very rapidly, which will be used for calculation purposes. Suppose different specific volume, enthalpy, air enthalpy, humidity, air enthalpy, relative humidity ratio. By this, we can calculate the capacity of the cold storage. Okay. So next class, I will discuss how to use or how will we calculate by these processes the capacity of the cold storage. Okay. I think all of you have understood. Okay. So bye for today. Okay. I am now just ending. Okay. Thank you, all of you. Okay. Bye.